This question wants us to solve 5 to the 2x plus 5 to the x is equal to 12, and although I prefer an exact answer, this question wants the answer given to 3 significant figures. If you've seen a question like this before, and you recognise it's to do with logarithms, or perhaps you've read the title of the video and you know it's to do with logarithms, you may be thinking, well, what's something we can do? We could take logs of both sides. So you may be thinking, let's take a log on the left-hand side, and let's take a log on the right-hand side. That seems okay? Well, no, I'm afraid not. Don't do that. To understand why we can't do this, we have to know and recognize the laws of logarithms. So one of the laws tells us that if we've got a sum of two logarithms with the same base, the answer will be the log of the product, like this. Similar rule can be used for minus. If, however, we were to take a logarithm of a sum, so a logarithm of x plus y, this would be nothing. This wouldn't be any rule in particular. So we can only use the top rule and we can never use the bottom rule. Instead, we've got to recognize that this is a hidden quadratic. It doesn't much look like one, but it's a hidden quadratic because there's a 5 to the x and there's a 5 to the 2x. So that's what you're looking at for. So for any quadratic, you want everything to be on one side. So what I'm going to do is I'm going to subtract the 12. And then we're going to make a substitution to make it easier for ourselves. So let's make y equal 5 to the x. That means that this middle term will be y, 12 is 12, and that first term is 5 to the 2x. So if we imagine this to the power of 2 is the same as y to the power of 2, or y squared. And looking at this, this is fantastic because we've solved a million of these quadratics before. So factorize it, it's going to be y plus 4 and y minus 3, which tells us that y is going to equal minus 4, or y is going to equal 3. But we're not done there. This is y, and we want x. So it tells us that 5 to the x is equal to minus 4, or 5 to the x is equal to 3. But 5 to the x cannot equal minus 4. That's because 5 to the x as an exponential can never be negative, so this has no solutions. 5 to the x equals 3 is okay. We can use a law of logarithms to rearrange this to get x is equal to log to the base 5 of 3. On some questions you can stop there, but this one wants it to 3 significant figures, so I'm just going to type it in on the calculator to get 0.6826061945 or 0.683 to 3 significant figures. Want some more?